Ever since blockchain became a thing, there's been this one problem, this one fundamental limit that has stumped pretty much everyone. It's a puzzle that forces every single project out there to make a really painful compromise. So today, let's dive into that puzzle and a project that claims it has finally actually solved it. And yeah, they are not shy about it. TOI Chain comes right out of the gate with this huge claim. They are the blockchain that solves the trilemma. They're talking about a whole new kind of protocol, a layer 0.5. So think of it like a new foundation that other blockchains can even build on. And they say it's designed for the entire globe with absolutely no compromises. Look, it's a massive claim, for sure. But if it's true, it could change everything. And that really brings us to the core question of this whole explainer. Decentralized, secure, scalable. The common wisdom, the law of the land in this space, says you can pick any two you want, but you can never, ever have all three. So, how on earth is this even possible? Let's find out. Okay, so before we can understand how TOI says it's broken the rules, we first have to really get a grip on what those rules are. So let's talk about the famous, or maybe infamous, blockchain trilemma. So what is it, really? Well, the blockchain trilemma, which was first really articulated by Vitalik Buterin, says that any blockchain design is basically in a constant tug of war. If you want maximum decentralization and rock-solid security, you're going to have to give up speed and scalability. And if you want crazy fast scalability, well, you usually have to cut corners on one of the other two. And this is what makes it so real. Take a look at Bitcoin. It's incredibly decentralized and secure, but we all know it's slow. Ethereum's kind of in the same boat, though it's getting better. Then you've got something like Solana, which is super fast, but it gets that speed by making some real trade-offs on decentralization. Now look at the bottom row for TOI Chain. High, high, and high. That's the claim. And this problem isn't just a blockchain thing. In traditional computing, there's this weird paradox. You'd think, hey, let's add a second server to back up the first one. That'll make the system more reliable, right? But a lot of the time, the exact opposite happens. All the work it takes to keep those two machines perfectly in sync, what they call synchronization overhead, can actually bog the whole system down and make it even less effective. All right, this is where the story takes a really fascinating turn. TOI's whole argument is that for years, everyone has been trying to solve the wrong problem. They're saying the issue isn't the trilemma itself, but the very foundation that everybody has been building on top of. And here it is. This is the big aha moment. The central idea from TOI is that the trilemma isn't some unbreakable law of physics. No, it's just what happens when you start with a single, fundamentally flawed assumption about how computers and networks are supposed to work in the first place. So this is the crucial difference in philosophy. The old way of thinking, the legacy way, just kind of assumes that hardware and networks should be reliable. And when they fail, it's a big crisis. The TOI shift flips that completely on its head. It starts from the opposite direction. It just accepts the statistical certainty that, yeah, individual parts are going to fail, and it builds a system that doesn't just put up with that unreliability, it's actually designed to thrive on it. Okay, so if you're going to embrace unreliability, how in the world do you build a system that's actually more reliable than anything that's come before it? It sounds like a total paradox, I know. But it all comes down to two core technological breakthroughs. Right, the two pillars of this whole thing are ASICN and SMC. Think of ASICN like this. Instead of going to a library and asking for a book on a specific shelf in a specific aisle, you just ask for the book by its title, and the system finds it for you no matter where it is. It finds data by what it is. And SMC? Well, that's like a giant dynamic choir. Even if a few singers are off-key or forget the words, the sheer number of voices all singing together creates one powerful, perfect sound. And this slide just illustrates the difference perfectly. Look over on the left, the old-school network. A request has to follow a very specific path. If any single connection on that path breaks, the whole thing fails. It's brittle. Now look to the right. With ACCAN, a request is just broadcast out into the network. It gets routed to any available computer that has the data, creating this amazing, resilient, self-healing web that has no single point of failure. Now let's build on that with the computing layer, SMC. This is the engine that actually runs on top of that ACN network. It dynamically groups computers together to perform tasks in these incredibly flexible ways. It can do one job on many pieces of data at once, or run a whole bunch of different jobs on different data, all in parallel. It can even chain computers together for really complex tasks. It's all about harnessing the collective power of the entire network, moment by moment. And here is the mathematical payoff. That dotted line, that shows a legacy system. As you add more computers, you get diminishing returns. The system gets bogged down by all that syncing overhead we talked about earlier. But look at the TOI chain curve. Because it's designed to leverage a massive number of unreliable parts, the more computers you add to the network, the exponentially faster it gets. More nodes literally equals more speed and more stability. So it's scalable, we got that. But is it secure and decentralized? Well, that's where the proof-of-stake consensus mechanism comes in. To approve a block of transactions, the protocol randomly picks a committee of validators. This randomization makes it incredibly difficult for any bad actors to team up or attack the network. And because the barrier to entry for stakers is low, it ensures massive decentralization. Now, this groundbreaking tech isn't just some idea on a whiteboard, it's the actual foundation for a complete four-part ecosystem, and it's designed to be the backbone of a whole new decentralized internet. So let's just quickly look at the full stack. At the very bottom, you've got the TOC chain itself, the core ledger. On top of that, the TOC gateway acts as the decentralized front door. Then you have TOC Cloud for super secure private computation. And finally, ACAN chips, which provide this unforgeable hardware-level security. I mean, it's a complete package from the silicon chip all the way up to the application. And the thing that powers this entire ecosystem is the TOIN token. It really has three main jobs. First, it's gas. You use it to pay for transactions and storage. Second, it's used for staking, so you can become a validator and earn rewards for helping secure the network. And third, it's your ticket to governance, letting you vote on the entire future of the protocol. The total supply is capped at around 50 billion tokens. And as you can see from this chart, the way they're distributing it is heavily focused on decentralization and long-term growth. A huge 30% chunk is set aside just for validator payments, with another 20% for community building. This is all about ensuring the network stays healthy and secure for the long haul. So what does the future actually look like? Well, TOI has laid out a really clear multi-year roadmap to go from this foundational tech to a fully autonomous, community-run organization. The whole roadmap is broken into three distinct phases. Phase 1, for the first couple of years, is all about building out core financial solutions. Then Phase 2 focuses on bridging the gap between the old Web 2 world and the new Web 3 world. And finally, in year 5 and beyond, the plan is to release the advanced hardware and, most importantly, hand over full control to the community through a DAO, making the network truly autonomous. So, when you put all these pieces together, the vision becomes crystal clear. The goal here isn't just to be another fast blockchain. The ambition is to become the fundamental trust layer for our entire global digital world, a world where value moves instantly and applications can serve billions of users without ever hitting a wall. And that leaves us with one last, pretty fascinating thought to chew on. For decades, we've been chasing perfect, reliable hardware. But what if that was the wrong path all along? What if the future of digital trust is built on the exact opposite idea? A system so cleverly designed that it can take an infinite number of unreliable parts and weave them together into a mathematically certain, perfectly reliable whole.